Good morning, ma'am.
Good morning. Very good morning. Chalo, call
Good
everyone.
morning, ma'am.
Good morning. Very good morning. Hello, student. Shall we start now? Hello, friends. Shall we
Yes,
start
ma'am.
now? Okay.
Yes, ma'am.
Can
Yes,
you
ma'am.
see
Yes.
Yes, ma'am.
the screen shared? Can you see the screen shared?
Yes, ma'am.
Yes,
Okay.
ma'am.
Yes.
So, last time your experiment was taken by Nagnath sir, isn't it? Very first experiment. Nagnath sir and Pawar sir. Was it taken
Yes,
by?
ma'am.
Okay. That was about error. Now for experiment one as well as for today's experiment.
Yes, ma'am.
Huh? Yeah. For both, I'm going to share the Google form, and you have to write down the observation, calculation, etc. in the Google form itself. And one or two question will be there with each Google form. You have to answer it. It will be checked, and you will get the marks out of 10 for the experiment. So Google Form, I am preparing it. Halfway it is done. How to introduce the observation, calculation, etc. image. That little bit I have to work on it. By maybe Saturday or Sunday morning, I will share it with you. And I will post it on the link on your WhatsApp group also. Immediately you open the link and submit the form, and on that after submitting, you just acknowledge that you have submitted the form. I'll check it. Now today's our experiment is we have to find out the temporary and permanent hardness by using ADTA. We have done this in the class, and I know that you all are very good students, scholar one, brave, brainy student. So you have understood what is ADTA long form. What is the long form of ADTS? Huh? Chalo fast.
Ethylene diamine
Tetraacetic
tetraacetic
acid,
acid.
tetraacetic acid. Now, hard water, we have defined that instead of good lather, it gives the curd-like precipitate with the soap solution. Soft water is the one which gives the good lather with the soap solution, and hardness is the soap consuming capacity. These three definition we have seen. Also, we have seen the definition of temporary hardness and permanent hardness. Temporary hardness is also called as carbonate hardness or alkaline hardness, and it is due to carbonates and bicarbonates which can be removed by boiling and filtration. Whereas permanent hardness is non-carbonate hardness. It is a revision, so I am taking little fast because 1 hour is not sufficient. Actually, the experiment is supposed to be for 1.5 hour minimum, even if you are not performing, but we have to manage it in 1 hour. That is why I have to go little fast, assuming that you know everything which I have taught you earlier. So permanent hardness is the one which is due to non-carbonate salts of calcium and magnesium, which cannot be removed by boiling and filtration. Now, if the hardness of water is between 0 to 75 ppm, it is supposed to be soft water. Without any risk, you can use it for every purposes, for domestic, industrial, and so on. If it is from 75 to 150, it is moderately hard. If it is from 150 to 300, it is hard, and above 300, it is very hard. So if it is 150 above, with a little risk, you can still use it for the domestic purpose, not for drinking purpose, but for the cooking purpose and washing the utensil, etc. But if it is very hard, you cannot use it for any domestic purposes. So that is there. This is the formula of ethylene diamine tetraacetic acid. If it is H here, if it is H here, ethylene means CH2 CH2 group, diamine means NH2 NH2 group. So the two hydrogen here and two hydrogen we have replaced by acetic acid group CH2 COH CH2 COH. Here also CH2 COH CH2 COH. So if the valency of nitrogen is here 4, so instead of NH2, we have made the 2 valency by the CH2OCOH. Now you will ask me acetic acid is CH3COH, but if you will write CH3 here, the valency of carbon becomes 5. So here CH2COH is acetic acid, and this is the structure of EDTA, ethylene diamine tetraacetic acid. Just I have shared it, so you prepare it for your MCQ examination in the theory, the structure of EDTA. That time also I had shown it to you. Now this is the uh, uh, this H is removed and it is replaced by Na, and then your calcium or magnesium, here it is shown the calcium or magnesium, it forms the complex with your EDTA, and it is called as metal ion EDTA complexes. Metal ion EDTA complexes. This is the structure of metal ion indicator complexes. We have seen the principle that you are, suppose that you are performing the experiment in the conical flask, you have taken the water sample, just add 2 drops of indicator, that is areochrome black tea indicator, in presence of alkaline buffer. Buffer was made up of what? I told you in the theory. Buffer was, which buffer it was, acidic or alkaline?
NH4OH.
4OH or
NH4,
N.
NH4Cl.
NH4Cl or NH4OH.
NH4OH, because when the hardness is there, the hydrogen ion concentration of the water is very high, due to which the pH of the water decreases. And for the hardness determination, we want alkaline pH, and for that purpose, we have to use the alkaline buffer, which is made up of NH4Cl, NH4OH. So if you take 5 ml of water sample, you have to add 3 ml of buffer solution and 2 drops of areochrome black tea indicator. What is areochrome black tea indicator here is, it is a indicator. So when you add indicator to the water containing metal ion, both Ca and Mg causes the hardness, so they have +2 charge. So I have shown metal ion here by M+2. Hin, it is your indicator presented, so it immediately react with M+2 ion to form this type of complexes. But these are complexes with indicator, not with EDTA, and it is called as metal ion indicator complex. It is known as metal ion indicator. Ion indicate indicator. Metal ion indicator complex, which is short-lived and wine-red. Short-lived means stable only for a short period, for a fraction of second, and it is wine-red. That is diluted blood-like color it has. So principle is that we have to use the buffer to maintain the pH 10 for hardness determination. We are using the indicator EBT. When it is added to the water sample containing metal ion, it forms the complexes with the metal ion, which are known as metal ion indicator complexes, which are shorter lived and they are wine red in color. Now, as soon as they are formed, immediately you have to add the EDTA from the burette. EDTA is H2Y minus 2. This is the short formula here. It is H2Y minus 2. It is the EDTA. So EDTA will react with your metal ion indicator complex, MIN, metal ion indicator complex. EDTA is powerful, so it will remove indicator from the place and it will form the complexes with the metal ion, and it is called as metal ion EDTA complex. It is called as metal ion indicator complex. But this indicator is recovered during the titration. It is thrown out during the titration. It is sky blue when it is prepared. So end point of the titration is wine red to sky blue. Wine red is due to formation of metal ion indicator complex, and sky blue is due to the recovery of indicator, because metal ion EDTA complexes are colorless. Now, if it is asked in the examination, describe the complexes formed with the indicator and the EDTA. EDTA here is a titrant. Already I have told you in the theory, it is a titrant. The solution which is to be taken in the burette is titrant, and the solution and which is to be taken in the conical flask is titer, TITRE. Now here indicator is EBT, area chrome black tea indicator. So the complexes with the indicator are short-lived. They are stable only for a short period and they are wine red in color. Whereas the complexes formed with EDTA, they are longer lived, they are colorless, but the indicator is recovered during the titration. Hence the endpoint is wine red to sky blue. Now we will see. So everything was discussed. So I took it little hurriedly. You want me to explain anything earlier from the theory process? Huh? Yes.
No, ma'am.
No. Okay.
No,
Now
ma'am.
what is the
No,
procedure?
ma'am.
There is a first part is you have to prepare the zinc sulfate solution. Try to understand that we have 8 division in one module. 8 division are there, per division 3 batches are there, practical batches. So 24 batches they have to perform the same experiment in the given week. So always the solution are prepared on Monday morning, 9 o'clock, etc. for all 24 batches. About 25 liter ADT is prepared by our lab assistant. So whatever the concentration when it was freshly prepared, same concentration is not observed at the end of say, Saturday for the last batch. And that is why every time before using EDTA, you have to find out whether the concentration of EDTA is required concentration or less, because the hardness depends on the concentration of EDTA. If concentration of EDTA is more, the corresponding hardness reading will be more and you will get the hardness properly. If you will assume that the concentration is 0.01 molar, and if it is not 0.01 molar, suppose it is 0.0096, it is less. So you will get hardness less than what is actual there. So every time it is necessary to find out the hardness before you are performing the experiment. And for determining the hardness, zinc sulfate is used as a standard. Now, why it is to be used? Because zinc sulfate every time we are going to prepare fresh. Because of this situation, you are earlier supposed to perform it in the lab, but now you are not performing. So imagine that you are doing the experiment here. So you have to prepare zero point zero 0.01 molar zinc sulfate 0.7H2O as a standard. For that, you have to take 0.718 gram of zinc sulfate powder. You have to dissolve it in minimum amount of water in the beaker, and then you have to place it. You have to transfer it to the volumetric flask. Volumetric flask is a long necked flask. If you will give the on Google, you will be able to see what is volumetric flask. So it is a long naked flask on which the marking is given 250 ml, 500 ml, 1000 liter capacity like that. So surely after the practical on Google, you just give the image of the volumetric flask, you will be able to see what is it actually. So you have to take that 0.718 gram of zinc sulfate powder, dissolve it in minimum amount of water in beaker. Beaker, you know what it is. Transfer that solution to volumetric flask, and up to 250 ml mark on every volumetric flask there is a mark indicating that up to that mark the volume of the solution is 250 ml, 500 ml, 1000 liter, etc. So the solution will be 250 ml. Now shake it upside down and then take the two burette. In one burette you take the zinc sulfate which you have prepared, and in one burette EDTA which is prepared. We have to find out what is the concentration of EDTA. So now in one burette, suppose always take in burette A, label it for your convenience. Burette A will have EDTA and burette B will have zinc sulfate. So you fill the burette up to the mark with zinc sulfate, B burette, and A with EDTA solution, disodium salt of EDTA solution. So why disodium salt? Because EDTA has no charge. We want Ca plus 2 and Mg plus to be replaced from the water. And for that some ion should be there for ion exchange. And that is why we have to use the disodium salt. If EDTA is there, it is chargeless, it is neutral. We want Ca plus 2 and Mg plus 2 ions to be removed from the water, and for that some ions should be there. And for one Ca plus 2 or one Mg plus 2, you know that two sodium ions are required. So to the formula is Na2EDTA. Are you getting me, or am I going little fast? Fast होते का माझं? Yes.
No, ma'am.
Oh, everyone, am I going little fast? तर आपण झिंक सल्फेट सोल्युशन केलेलं आहे ते आपण एका ब्युरेट मध्ये घेणार आहोत. एका ब्युरेट मध्ये EDTA ज्याचं कॉन्सन्ट्रेशन आपल्याला चेक करायचं आहे. Now, from that burette B, we will take 5 ml zinc sulfate in the conical flask. तुम्ही मला विचाराल pipette का नाही वापरायचं? तर pipette is less accurate than burette. So from burette, you will take 5 ml of zinc sulfate in the conical flask. You will add 3 ml of buffer. Buffer is a strong buffer. So you have to use the measuring cylinder, not the pipette. If you will use the pipette, then that buffer, if ammonia goes to your throat, then permanently you will not be able to speak at all. Have you got it? And that is why you have to use the measuring cylinder. If you want, you can see the picture of the measuring cylinder also on the Google. So take 3 ml of buffer, 5 ml of zinc sulfate in the conical flask from the burette, 3 ml of buffer, 2 drops of areochrome black tea indicator, and fill the burette A with the EDTA solution. Go on adding EDTA till the color changes wine red to sky blue. असं एक रीडिंग घेतलं. असंच आपल्याला टोटल 3 रीडिंग्स घ्यायचे आहेत. Again, you watch the note down the reading. Suppose the reading is 5 ml. Suppose the reading is 5 ml. Now throw the content of the conical flask in the basin and wash it properly. Again, take 5 ml of zinc sulfate from burette B. Again, add 3 ml of buffer to it and 2 drops of areochrome black tea indicator. Fill the burette with EDTA. Already in burette A, EDTA is there. Go on adding EDTA till the color change again wine red to blue is sky blue is observed. I have explained you nicely why the wine red to sky blue color is there at the end point. So this way you have to take the 3 readings. Suppose your first reading is 5 ml, second is 5.2, third is your 5.4. So what is the mean of this? 5, 5.2 and 5.4. These are the 3 readings. So what is the mean of this? These are the 3 readings, burette reading. याचं mean काय येईल? Are you attentive, L1 batch?
Yes, ma'am.
So what is the mean of this? What is the mean of this? चलो 5, 5.2 and 5.4. त्याचं mean किती येईल?
5.2.
5.2.
5.2.
मग एवढा
5.2.
त्याच्या कॅल्क्युलेशन मी लगेच सांगते. आपल्या ब्युरेट ए कंटेन EDTA, ब्युरेट बी कंटेन झिंक सल्फेट विच वी हॅव प्रिपेअर्ड. इंडिकेटर इज एरियोक्रोम ब्लॅक टी इंडिकेटर आणि एंड पॉइंट इज वाइन रेड टू स्काय ब्लू. दिस इज द मेटल आयन, दिस इज द इंडिकेटर, this is the metal ion indicator complex which is short lived and wine red. Then EDTA is added to this, you will get metal ion indicator EDTA complex which is longer lived and colorless here, but the indicator is recovered. The color of the indicator is sky blue, so hence the end point is wine red to sky blue. Now this is the observation table for first part. First reading is 5, second reading is 5.2, third reading is 5.4. Note down these 3 readings because we are not going to perform this practical here. Write down this reading. These are given by me because we have observed this when we did this experiment last year. So the reading is 5 ml, 5.2, 5.4. So your mean or constant burette reading is 5.2 ml. Are you with me? Are you with me?
Yes, ma'am.
Yes, ma'am.
Now you have to
Yes, ma'am.
okay, you have to use the equation M1V1 is equal to M2V2. M1V1 is for zinc sulfate, M2V2 is for EDTA. Zinc sulfate, you have prepared it freshly. You know the concentration 0.01 molar. How much zinc sulfate you have taken for titration? 5 ml. So 0.01 into 5. EDTA molarity you have to find out. What is the burette reading? That is your V2. V2 is your burette reading. What is the burette reading I told you here? What is the burette reading here? Mean burette reading or constant burette reading?
5.2.
5.2.
5.2.
So M2 you have to calculate, that is concentration or strength of the EDTA you have to calculate at the time of performing experiment. For every batch it will not be same. As the time passes, the strength decreases. That is why exact strength we want for calculating the hardness. So every batch will do this experiment, has to do this when they are doing the hardness determination. So M2 is equal to 0.01 into 5 divided by X. 0.01 into 5 divided by 5.2. Calculate how much is M2. 0.01 into 5 divided by 5.2. चलो calculate करो.
1.8 into the power minus 3.
0.0018. Huh? 0.0018. Is it?
Yes, ma'am.
Okay, so it is 0.0018. Check it once again. So this is our first part, standardization of EDTA, in which we have to find out what is the exact concentration of EDTA when you are performing the experiment. Now, so preparation of, excuse me, preparation of zinc sulfate was first part, standardization was second part. Now third part, we have to find out total hardness. Just please excuse me, I'll drink water and I'll talk to you. So first part was preparation of zinc sulfate, second part was standardization, and third part we'll find out what is total hardness of water sample. What is the total hardness of water sample? Now when you boil the water sample, which hardness get removed? By boiling,
Temporary hardness.
temporary hardness is removed. So before boiling, the water is supposed to have total hardness. So whatever sample is given to you, usually we are giving the water sample from the washroom. One of the tap water sample, we are giving it for testing the hardness of the, whether it may be from ladies washroom or from gents washroom, from the tap of that basin tap we are giving. So suppose you have given a water sample in the beaker. So fill the, now for a second part, we have to determine total hardness. So that basin water which is given to you, you have to fill it in burette B. In burette A, again, same EDTA. Fill the burette A with the EDTA and fill the burette B with the basin water, and take 5 ml of that basin water in a conical flask with the help of burette. Add 3 ml of buffer solution with the help of measuring cylinder. पिपेट वापरायची नाही, नाहीतर तो पूर्ण घसा तुमचा जळून जाईल. अमोनियामुळे पूर्ण घसा जळून जाईल, तुम्हाला आयुष्यभर बोलता येणार नाही. So you have to take the buffer solution which is alkaline to maintain pH 10 for hardness determination with the help of measuring cylinder, and you have to take 2 to 3 drops of Ariachrome black tea indicator. So in conical flask, you have 5 ml basin water, you have 3 ml buffer and 2 to 3 drops of Ariachrome black tea indicator. You have filled the burette with EDTA solution and go on adding EDTA till you get the endpoint wine red to sky blue. And in this way, you have to take 3 readings. Every time you have to throw the content of the conical flask, take the fresh water, basin water, add buffer to it, add Ariachrome black tea indicator, titrate it with EDTA. Same procedure you have to follow 3 times and find out what is YML. Now again, you are not going to perform it, so I am going to share the last time's reading with you. Have you understood the procedure here? Total hardness ka?
Yes, ma'am.
Okay.
Yes,
So
ma'am.
Yes, ma'am.
Yes, ma'am.
calculation for determining the uh, total hardness of water sample. Total hardness. Burette A, you have the EDTA whose molarity you know that it is 0.0018. Then in burette B, your water sample, basin water sample is there, which you are testing for total hardness. Indicator Ariachrome black tea, endpoint is wine red to sky blue. This is already we have seen that your indicator will react with Ca plus 2 or Mg+2 to give metal ion indicator complexes. These are these are short-lived, means stable only for few seconds, and they are wine red in color, diluted blood like. From burette you are adding EDTA. EDTA being more reactive, it will take the place of indicator, and indicator is kicked out or recovered during the titration, and therefore the end point is wine red to sky blue. These complexes are short-lived. They are stable only for short period, but they are wine red in color. And the complexes with EDTA, they are longer lived and they are colorless. But indicator is when freshly prepared, it is blue. So the end point is wine red to sky blue. Now for second part, I'll give the reading, write down the reading 3, 3.2, 3.4. Write down the reading 3, 3.2, 3.4. So what is the mean of this? What is the mean of this?
3.2.
3.2 is your YML.
3.2.
Yeah, okay. Now these are the calculation. This is the relation. You will ask me from where it is. It is the reactivity coefficient. It is there available in the literature, practically proven. So it is observed that 1 mole of EDTA is in reactivity equal to 1 mole of Ca plus 2 or Mg+2 CaCO3 equivalent hardness, which is equal to 1 mole of CaCO3 equivalent hardness. 1 mole of EDTA is 1 mole of CaCO3. But 1 mole of CaCO3 means 100 gram of CaCO3. Why 100 gram? Why 100 gram?
Because
Yes.
CaCO3's molecular weight is 100 gram.
100. Huh? So 1 mole of CaCO3 is 100 gram of CaCO3. But unit is gram, not milligram. So 1 mole of CaCO3 is nothing but 100 gram of CaCO3. Now we'll see what is 1 mole of EDTA. 1 mole of EDTA means 1 liter, 1 molar EDTA. 1 mole of EDTA is nothing but 1 liter. 1 liter is 1000 ml. So 1 mole of EDTA is nothing but the 1 liter, 1 molar EDTA. So it will be equivalent to 100 gram of CaCO3 from this equation. 1000 ml, 1 molar EDTA is equivalent to 100 gram of CaCO3. Now it is in gram. We want to convert it in milligram. So what we have to do? We have to multiply by 10 raised to 3. हे जे 100 आहे त्याला we will multiply it by 10 raised to 3. So 10 raised to 2 into 10 raised to 3. How much it is? 10 raised to 2
10 raised
into
to
5. Huh? 10 raised to 5. So it 1 liter means 1000 ml. Now here we have taken 1 ml. So we have divided here by 1000. So 10 raised to 5 also we will divide by 1000. How much you will get? 10 raised to 5 divided by 10 raised to 3. How much you will get?
10 raised to 2.
10 raised to 2. But unit will be milligram. Huh? Earlier we have converted into milligram by multiplying by 1000. So now when you will divide it by 1000, unit will be milligram. Now how you will get 1 molar converted to 0.01 molar? By what you have to divide? 1 molar का 0.01 convert करना है 0.01 में. So you will divide by what?
10 raised to 5.
1 molar to 0.01 molar. You have to divide by 100. 100. एक 1 मोलर पासून 0.01 मोलर कसं मिळेल? तर 100 ने डिवाइड करायचं. Please understand everyone. What is 1 mole of EDTA is nothing but 1 molar 1 liter EDTA. And what is 1 mole of CaCO3? 100 gram of CaCO3. So 1000 ml 1 molar is EDTA is equivalent to 100 gram. So instead of 1000 ml we made it 1 ml. So it will be how many gram? 10 raised to 2 into 10 raised to 3 means 10 raised to 5 milligram. Are you with me?
Yes, ma'am.
Everyone I want answer.
Yes, ma'am.
Okay.
Yes, ma'am.
So 10
Yes,
raised to
ma'am.
5. हा आता इथे 10 raised to 5 मिलीग्राम झालं. पण येथे 1000 ml च्या ऐवजी आपल्याला 1 ml हवंय. So we have divided 1000 by 1000. So here also we will divide 10 raised to 5 by 1000. So how much you will get? 10 raised to 5 divided by 10 raised to 2 milligram, म्हणजे 100 milligram. Huh? Here 1 molar is there. We want 0.01 molar. तो किससे डिवाइड करना पड़ेगा इसको? 10 से डिवाइड किया तो कितना आएगा? 0.1 आएगा. 100 से डिवाइड किया तो 0.01 आएगा. तो यहाँ पे जो 100 मिलीग्राम आया उसको 100 से डिवाइड किया तो 1 मिलीग्राम आया. Have you understood or no?
Yes, ma'am.
Yes, ma'am.
Okay. Just excuse me. I am getting phone. I'll give it to my son. Kaustubh, phone ge beta. So here, how many of you have understood this calculation? Chalo, please raise your hand. How many of you have understood the calculation? Huh? Only two. Only two students have understood the calculation. Not else. 5. Chalo fast. 6. Shall I explain it again? You want me to explain again? Yeah, it's rising. 13.
No, ma'am.
14. Okay. So 1 ml 0.01 molar EDTA will be equivalent to 1 milligram of CaCO3. Now आपका YML कितना है? How much I told you? What is YML? 5, 5.2, 5.4. So what is Y? What is Y? Mean of this? 5.2. So Y is here 5.2. What is M2 here? What is M2 here? 0.0018. Huh? 0.0018. Huh? Yes? Do the calculation. I think there is something
Yes, ma'am.
mistake. 0.0018 is not correct. And find out what is exact value. So 5.2 into 0.0018 into 1 divided by 0.01 will be your a milligram of CaCO3 equivalent hardness, which is present. How much it is? 5.2 into 0.0018 into 1 divided by 0.01. How much it is? How much it is? Calculate this A. We will call it as A. Chalo fast. How much is this A? 5.2. Am I audible to you? Am I audible to you?
Yes, ma'am.
Okay,
Yes, ma'am.
so 5.2 into 0.0018 into 1 cross multiplication divided by 0.001. What is the answer you are getting? What answer you are getting? What answer you are getting? Chalo, calculator पे करो ना fast. What is Y? What is Y? Huh? You do not have
0.
calculator?
0.936.
Huh?
0.
0.936.
0.936. Huh?
9.36.
Huh?
9.36. 9.36.
9.6. Huh? Yes. 9.6 or
9.36.
9.36. It is present in how many ml water? How much water you have taken for titration? How much water you have taken for titration? 5 ml.
5 ml.
5 ml में 9.36. Huh? So 1 liter में कितना होगा? So you multiply that by 200. Is it 0.936 or 9.36? Do it correctly. I'll give you Y is your 5.2, M2 is 0.018. It is actually wrong. It should be 0.096. Correct answer here. The girl who has given the answer is wrong. This answer is wrong. It is 0.096 something or 98. Here it is 0.096. I do not have calculator. Please do the calculation. How much it is? M2 is how much? अरे बोला रे बायांनो, नाही तर एक्सपेरिमेंट होणार नाही, परत घ्यायला लागेल आपल्याला. डू द कॅल्क्युलेशन. M2 चा आन्सर करेक्ट सांगा मला. What is M2 here? 0.01 into 5 divided by 0.01 into
0.0096.
5.2, huh? 5.2. How much it is? How much M2?
0.0096.
0.0096. So earlier it was wrong. I made a mistake here. The reading is 3, 3.2 and 3.4. Y reading is 3, 3.2 and 3.4. So Y is 3.2, mean reading. 3, 3.2 and 3.4. Mean is 3.2. So you substitute the value of Y as 3.2 into 0.096 into 1 divided by 0.01. Give me the answer. कळले का सगळ्यांना? You want me to explain all this again? Please do not waste time. If you want, I will explain it again. You want me to explain this again? Say yes or no.
No, ma'am.
No. मग हे सांगा. 3.2 into 0.096 into 1 cross multiplication divided by 0.01. किती आन्सर येते सांगा?
30.72.
30.72.
30.72.
30.72. It is present for 5 ml. So for 1 liter, how much it will be? Multiplied by 200. Multiply this value by 200.
6144.
6144.
6144.
6144.
तुमच्या कॅल्क्युलेशन चुकतात रे बायांनो. इतकं नाही, 1000च्या वर येत नाही हार्डनेस. एका डेसिमल पॉइंटचं चूक करताय तुम्ही. करा बरं. 3.2 into M2 is what? 0.0098. 0.0098 divided by 0.01, 98 or 96. It cannot be 0.09. तुमचं बेसिक कॅल्क्युलेशन चुकतंय. परत करा. M2 is 0.0098.
615. Answer is 615.
615 is correct. कळतंय का तुम्ही कुठे चुकला इथे? M2 किती असायला पाहिजे तुमचा? 0.0098 किंवा 96.
96.
96 आहे ना? 2 0 आहेत ना डेसिमल पॉइंट नंतर. The one who had answered me, the girl, please check the calculation. It was not 0.018, but it was 0.018 might be. Earlier reading, I gave you 5, 5.2, 5.4. So 5.2 was mean. Now 3, 3.2, 3.4. So 3.2 is your mean. So 3.2 into 0.098 divided by 0.01. So you will get, what is A? What is your A? Chalo, give me A. अरे बोला ना, एवढं सॅम्पल कॅल्क्युलेशन आहे हे. मॅथ्स कॅल्क्युलेटर आहे ना तुमच्याकडे? प्लीज बोला. M2 किती आलं? What is your M2 value? What is your M2 value?
0.096. 0096.
हा 0.0096 त्याला 3.2 ने मल्टिप्लाय करा आणि 0.01 ने डिवाइड करा. किती येते आन्सर सांगा?
3.072.
हा किती आला?
3.072.
3.02.
3.072.
हा
3.072.
ओके 3.072 हे 5 ml ला आहे. मग 1 लिटरला 5 रुपयाला मला एक पेन मिळतं, तर 1000 रुपयाला किती पेन मिळतील मला?
614.4.
641.4 is the correct answer. Which is this hardness? Total, permanent or temporary? Have you boiled the water sample?
Yes.
Have you boiled the water sample here? बॉईल करून घेतलंय का पाणी तुम्ही? बेसिनचं पाणी आहे तसं घेतलेलं आहे, बॉईल केलंय का तुम्ही?
No.
Yes,
No,
Abu?
ma'am.
No, so it is total hardness. 6, how much is total hardness?
614.4.
641.4. Is it? हा कळलं नसेल तर विचारा बाळांनो, मी चिडलेले नाही.
614.4.
किती आलं टोटल हार्डनेस? टोटल हार्डनेस किती आला? किती आला?
614.4.
6 किती?
मॅम
641.
614.4.
614.4. हा करेक्ट? Correct or
Yes,
wrong?
ma'am.
Yes, ma'am.
Okay, so that is your total hardness because you have not boiled the water. या कॅल्क्युलेशन परत एकदा सांगू का? काही कन्फ्युजन आहे का? Do you have any confusion? 1 mole means 1 mole of
No, ma'am.
CaCO3. 1 mole of CaCO3 means 100 gram because it is molecular weight. But 1 mole of EDTA means 1 molar 1 liter. 1 liter means 1000 ml. So 1000 ml के लिए 100 gram. तो 1 ml के लिए 1000 ml के लिए 100 gram means 10 raised to 5 milligram. So 1 ml के लिए 10 raised to 2 milligram. Here 1 molar is there, here 0.01 molar is there. So here 100 divided by 100, you will get 1 milligram. So Y is your 3.2, 3.2, 3.4. So Y is 3.2. So Y into 0.0098, 2 times 098 or 96 divided by 0.01, you will get A. It is present in 5 ml. So in 1 liter, you get 614.4. That is the total hardness. कळले का? Say something,
No,
yes
ma'am.
or no? Everyone.
Yes, ma'am.
Everyone.
Yes, ma'am.
Yes, ma'am.
Okay, so first part was our zinc sulfate preparation. Second part was our standardization of EDTA. Third part was our total hardness. Now, same basin water, you boil it for 10 to 15 minutes. You filter it. So you will remove the temporary hardness and then you find out what is the permanent hardness with that boiled water and filtered water. So the same basin water which was given to you, you boil it for 10 to 15 minutes and filter it. So whatever the impurities are there, temporary hardness, it will precipitate out. Remove that precipitate by filtration and use that water for determining permanent hardness. Use that water for determining permanent hardness. Have you got it? So the procedure is same again, like this. So you have to find out the permanent hardness now. For that purpose, whatever basin water is there, you have to boil it for 10 to 15 minutes. You have to filter it and that you have to fill it in the burette B, the filtered water which will have only permanent hardness. The filtered water which will have only permanent hardness. So that water you have to take it which will have only permanent hardness. So that you have to take 5 ml, add 3 ml buffer again to have the alkaline pH, 2 drops of Ariachrome black tea indicator and titrate it with EDTA. Repeat the same procedure 3 times and constant burette reading is ZML. पहले के लिए मैंने दिया था रीडिंग जिंक सल्फेट टाइट्रेशन के लिए. फर्स्ट पार्ट रीडिंग आई गेव इट टू यू, जस्ट नोट इट डाउन. दिस वाज फॉर EDTA, it was 5, 5.2, 5.4, so X was 5.2. Second part total hardness के लिए 3, 3.2, 3.4, so mean was 3.2. Now third part reading, will it be greater than 3 or less than 3?
Yes, then.
Yes, everyone, I want answer. Total hardness ज्यादा होता है क्या? Permanent hardness will be greater. Which one will
Total.
be greater?
Total.
Of course, total.
Total.
तो total
Total.
के लिए हमको 3.2 मिला, तो permanent के लिए should we get above 3 or below 3?
Below 3.
Below 3.
हाँ, so
Below 3,
for
ma'am.
this third part, you write down the reading 1.5, 1.7 and 1.9. Write down the reading 1.5, 1.7, 1.9. All these calculation you are going to write it. By Monday positively I will submit the Google form. I will share the Google form. You have to write the calculation observation in the Google form, and you have to write it in the notebook. You have to scan it and you have to upload it on the Google form. That facility will be given to you, and as soon as you will submit, I will check your and you will get the marks out of 10. Along with this observation and calculation, you will have 2 or 3 questions also. For that, you can refer to Google also for writing the answer of that questions. So you can do that, and immediately after the sharing, within a day or two, you have to submit the Google form, so that I will assess them and I will give the marks, and at last finally you will be able to see the marks. Have you understood the procedure? Again, same calculation for टोटल हार्डनेस, परमानेंट हार्डनेस. टोटल हार्डनेस के लिए जो कैलकुलेशन किया था अभी सेम कैलकुलेशन. ब्यूरेट A you have EDTA, ब्यूरेट B you have the boiled filtered water. Indicator is Eriachrome lacti. End point is wine red to sky blue. Again same reaction are there. Here 1.5, 1.7, 1.9. So it is 1.7. Substitute 1.7. M2 is your same 0.0096, 0.0096, 0.0096. That you have to substitute here. So Z is your 1.7, which I have given you here. 1.5, 1.7, 1.9. So constant reading is 1.7. So 1.7 into 0.0096 into 1 divided by 0.01. Give me what is the answer of B. What is the answer of B? Chalo, do it fast. 1.7 into 0.0096 into 1 divided by 0.01. Give me the answer of B. Chalo, fast.
1.632.
1.632.
1.632.
So it is present in 5 ml. So in 1 liter, how much it will be? Milligram per liter is ppm. So in 1 liter, how much it will be?
326.4.
Huh? 326.4.
326.4.
326.4.
0.4.
Now we will see the result table. The strength of the EDTA 0.0096 or 98, whatever you got. Total hardness, how much it was? 614.4. Permanent hardness is 3. कितना है? How much is permanent hardness? अभी कितना बोला आपने?
326.4.
326.4. So permanent, total minus permanent will be temporary. That is your result table. That will be your result table. Just go through the whole procedure, etc. and ask me if anything is not understood. Theory already we have discussed it nicely. Why the endpoint is wine red to sky blue, which two complexes are formed, what are their nature, which indicator is used, why buffer is used, what is the pH by buffer, which buffer is used, acidic or alkaline, and then the calculation.
Ma'am, can we share this manual?
It is already shared to your group, L division group, yesterday itself. You just check it out. It is
Okay,
checked
ma'am.
already yesterday only.
Okay, ma'am.
Huh? I will give the Google form. Till that, on notebook, you write down everything, observation, calculation, and question answer. Question answer will be there on the Google form. You have to write it in the notebook. You have to scan it and you have to upload it on the Google form. And then I will assess it. That process is still going on. By Monday, positively, you will get it. Huh? After that, I will give 2 or 3 days for completion. Huh? Till that, keep this ready. Have you understood, everyone? Now I will share.
Yes, ma'am.
Now I will share the attendance sheet. Before that, don't leave the class. Write down the attendance. Use your VIIT mail ID. Don't write don't submit the same form 2 times. Don't send the same form 2 times. You will be marked present only once, not for 2 times. Submit it fast, then we'll end up the meeting. I will share the Google form, complete it. I am thinking of designing it. As soon as I will be successful, I will share it. Are you through with the attendance? Are you through, all
Yes,
of
ma'am.
you?
Yes.
Shall I end up the
Yes,
meeting?
ma'am.
Okay, have a good day.
Yes.
If you have any query, you feel free to call me anytime in the evening, 6 to 10. Huh?